The same multi-agent system and the same results, 121 in LangGraph and 35 with the OpenAI Agents SDK. You know that feeling. You just want two agents to password between each other and suddenly you're writing state schemas, conditional edges and reducer functions. Half your code isn't even the agent logic, it's framework plumbing. OpenAI built an SDK that replaces all of that with 3 primitives, and the trade-offs aren't what you would expect. So OpenAI shipped the Agents SDK as a replacement for Swarm back in early 2026. The whole thing runs on 3 primitives. An agent is just an LLM with instructions and tools attached. A handoff lets one agent pass control to another, and a guardrail validates what goes in or comes out. That is the entire model. No state graphs, no edge definitions, and no reducers. Here's the core difference. In one graph you define a graph, wire up every edge, and manage state explicitly. With the Agents SDK, you just declare your agents and tell them who they can hand off to. The SDK handles routing and state internally. Now don't get me wrong, that simplicity has real trade-offs that we will hit as we build. Alright, let's get into it. Let's get the project set up. We need the OpenAI Agents SDK and Pydantic for our schema. We will also grab python.m so we can load our API key from a .m file. After that we create the .m file and set our OpenAI API key. Next we create the schemas.py file. Before we write any agents, we need to define what they return. We have 2 agents, a researcher that gathers info and a writer that turns it into a summary. Only the writer gets an output schema though because it's the last agent in the chain. The research agent doesn't need one. It hands off to the writer instead of producing a final result itself. We also define a topic check model for our guardrails. That boolean field is how we will decide whether to block a request or let it through. After that we create our main.py file. We're going writer first because the research agent needs to reference it for the handoff, so it has to exist already. An agent takes a name, instructions and an output type. Notice we're passing our Pydantic model as the output type. The SDK forces the LLM to return valid JSON matching that schema. There is no parsing and no validation code on our side. It just works. Before we create the research agent, let's build the guardrails it's going to use. This is that validation layer we talked about. We create a small agent that checks whether the input is a real research topic. It returns a topic check with a boolean and a reason. Then our guardrail function runs that agent and uses the boolean directly. If isValidTopic is false, we set tripwire trigger to true and the whole run stops. No tokens wasted on a query that doesn't belong. And we're using a structured Pydantic output here instead of string matching. It's way more reliable than checking if the word valid shows up somewhere in the response. Now we can build the research agent with everything attached. This is that handoff concept from earlier actually working in code. The handoff's parameter points to the writer. When the researcher decides it has enough findings, it passes control directly to the writer. And notice there's no output type here. That's the key detail. If we gave the researcher its own output type, the SDK would let it finish the run by itself. It would never need to hand off. By leaving it out, the only way this agent can complete the run is by delegating to the writer. We also attach the guardrail we just built. The SDK runs it before the agent processes anything. Alright, let's tie it all together. We call runner.run with the research agent and the topic. What happens next is the full pipeline. The guardrail validates the input, the researcher processes the topic and gathers findings. Then it hands off to the writer, which produces the final summary. All of that from one function call. Check the last agent in the output. It should say writer and not a researcher. That tells you the handoff actually worked. Let's see it in practice. Let's open the terminal and run our agent. As expected, we can see the final output and that the last agent was the writer. Now let's make sure the guardrail actually works. Change the input to something like tell me a joke. And now let's run our agent once again. This time you should see our guardrail tripped message instead of any agent output. That means the boolean check caught it and killed the run before anyone spent tokens on it. Alright, so now you have got a multi-agent system running on the OpenAI Agents SDK. Agents hand off work to each other, guardrails catch bad input and you wrote maybe 35 lines to get there. You also have the LangGraph version side by side, so you can actually see where the extra complexity buys you something and where it doesn't. Here's what I would do next. Take an agent you have already built and try porting it to the SDK. See if the trade-offs work for your use case. And if you want more hands-on builds like this, hit subscribe. I'll catch you in the next one.